Hey, topping Life Math Industry, and we are going to take a look at imaginary numbers. So, to kick start the video, what we're going to try and do is do a warm-up. So, for now, let's just solve for x. So, what we could do is the square root method. So, subtract by 1, subtract this side by 1. X squared equals -1, square root that, and square root that. X equals the square root of -1. You can't really do that because you can't square root a negative number. Because it's not like you can do that. If you multiply a negative and a positive, it's going to be a negative. But you can't really do that with a negative number. So therefore, it's no solution. But after this video today, we can understand that we may no longer need to use no solution because it's at a different problem. So, this is where imaginary numbers come in. So, mathematicians actually created imaginary numbers to help us understand that in some dimensions, the parabola that looks like this, that represents the last problem, may actually try to get to 0 in a different angle. If I try to do this, so the parabola faces us, on an xy coordinate, it wouldn't really work. But if you replace it with a z coordinate and measure 3D coordinates, then it would work. Imaginary numbers are also helpful to understand. Well, if it did exist in real life, then we would understand what it would have looked like. So, in that case, we get to use our imagination. So, we're going to understand imaginary numbers so we can solve this problem without saying no solution. So, here's how it works. It is kind of like a new number system, but it's similar to the one that we've been studying in algebra. The square root of a negative number property. If you have a negative square root right over here, then if you would rewrite it using the letter I, then you would have I radical R. So let's try to actually solve that problem into solving the same problem as last time. So here's what happens. Subtract by the 1 like last time. Subtract this side by 1. So -1 equals x squared. Now we have to square root that. And then we have to square root that. So then we get x equals radical -1. Which we did say in the last version right over here. Which we would have said no solution. But due to the rule way up here, if we just move that negative sign to the other side by replacing it as r, we could get it to seem like a number without a negative sign in it. Mathematicians earlier, back 100 to 200 years ago, they were afraid to use negative numbers or to have a negative in their numbers as an answer. So, to change it around, here's what would happen. We would have I to the radical of 1. When you have I to the radical of 1, that's because it represents this. Now that's easier to understand. So instead of saying no solution, I to the square root of -1 is going to be our new solution. Yay! When we play around with I, there are some other notices that will help us understand higher level math and get us prepared for higher level thinking. So we have been playing around with I. The two things that we should be reminded with I is going to equal the radical of -1. Which, yeah, we pretty much see right over here in the last problem. But, what if we also say, if you have I squared, that is going to equal -1 just by itself. The reason why is because when you have a square root and a square root multiply by each other and they have the same value, they cancel each other out and just have that value. So that's why we have I squared equals a -1. So what we're going to do before the video ends is some practice problems. So we're going to try to simplify using the rule way up here to simplify them out. So the first one, the radical of -25. What can we do? Well, we can do the square root of -1 multiplied by the square root of 25. Because -1 times 25 is a -25. This can be transformed into the letter I because of the rules right up here. But 25, we could have 5. So we have I5, high 5. What we could do is usually we want to have a number first, then the letter I. So our final answer is 5I. So yeah, high 5! The next one is going to be a little bit different. We have -72. What we could do is the square root of -1 and the square root of 72 and multiply them to each other. The -1 square root is just helping us get to the letter I. In general, the rule literally states that I need to do the I. So, we can turn this into the letter I. And not only that, we can put 8 and 9 right over here. So we have 9 is a square. So we can transform it into 3 radical 8. Because 3 times 3 is 9. But 4 and 2 also go into 8. And the 4 is also a square. Multiply that. So now we have I6 radical 2. Wait. Didn't we say that I had to be right behind the number? Yeah. So our final answer is 6. I radical 2. When you have a number, a letter I, and a square root, generally the I would be right behind the number and in front of the square root. The last one is going to be, it's going to be a little bit different than the last ones, but it's going to be very interesting. We have a negative number right in front of the square root. What are we going to do? Well, let's repeat the drill as if we were doing a square root. So, the square root of -1 multiplied by the square root of 3. Or the square root of 3. This becomes the letter I. And the square root of 3 is just going to be... It's just going to be the square root of 3. This method is not going to work. So let's try to rethink the problem. So here's the problem again. Notice we have a -5 and a -9 in a square root. We can transform that magically to have -5 multiplied by 3i. The reason why is we can apply 3i with this, the top rule, I equals square root -1. So when you multiply that, you get an answer of a -15i. So that is going to be the final answer, right over here. I spy with my little eye the right answer. So yeah, we now have imaginary numbers. Did you know that when we use negative square roots before we started learning about imaginary numbers, guess what our math teacher would always say? She would always be like, no one can square root negative numbers in my class unless I say so. I hope this video has helped you understand imaginary numbers. Thank you for watching Top Penalized Math Industry. Like and subscribe.